Welcome friends, welcome back. From today onwards we will start sorting different kinds of algorithm, and we will start from very basic algorithm, that is insertion sort. Before proceeding, I would like to really ask that whether you have seen that video of asymptotic notation or not, because asymptotic notation is very basic and fundamental concepts of the algorithm. So if you didn't see that video, please go back to my channel, that is algorithmisfun.com. Algorithm is fun on the YouTube, and you can find it over there. Okay, so let's start how insertion sort works. First of all, the first thing I would like to ask you all, do you know how human mind works, how human mind sorts an array? You'll be very excited to listen this. Human mind sorts exactly as the insertion sorts. See how, suppose I'll give you over some cards, and I'll tell to sort the cards. Now what will you do? You will check whether first card, then the second card, both the cards are in the ascending order, so there is no need to do anything, like both the cards in ascending order. Then check third card. Now see, third 3 should be less than 8, so actually 3 should be replaced with 8, and then 3 should be compared with again 7, 3 should be replaced with 7. So when you do these things, you don't really check each and every pair, but your eyes take care of these things, and it directly gives you final answer where the card 3 should come there. But when you analyze it very slowly, you will come to know your mind always works the same way. They uh, they compare with the elements with the pairs, and then arrange in the proper position. So here we have first 3 cards in the proper way, proper sorted way. Now check the last one. Yes, 5 should be compared with 8, so 5 should come over here. 5 would compare with 7, 5 would come over here. Now no more need to exchange. So this is the perfect sequence: 3, 5, 7, and 8. This is how insertion sort works. Don't worry, we'll see some more in the depth also. Let's see. Let's go from the imagination. We'll not follow the pseudocode, because I personally believe if you start with the pseudocode or program code, it's better to go with first imagination, how that algorithm works, some videography or some imagination, so that you can easily understand pseudocode or program. Here at the initial we'll always keep j on the second position, and I would be j minus 1. So it's obvious at the starting I would be at the first position. Here the stick represents that the elements on the left are going to be sorted in this pass. So we'll start from sorting first one element, then two element, three element. The same way we'll proceed. Let's see how it works exactly. First of all, let's compare I with I plus 1th element. So we'll compare 24 with 15. Oh, we need to change it because 15 is less than 24. Okay. Now actually I proceeds on the left side, but here we don't have any more elements, so we'll increment just jth pointer. So incrementing jth pointer, now our intention would be to sort first two elements. So our intention would be to now arrange the first two elements. So now again I would be j minus 1 compared to I with I plus 1. Oh, 20 should be at the left because it is less than. Now move your I pointer towards left side. Compare I with I plus 1 with 15 with 20. It's alright. 15 is less than, right? So we'll just proceed with incrementing j array, j pointer, sorry. Now our intention is to arrange the three elements. So now one more time I would be j minus 1, compare I with I plus 1. Oh, wrong order, so decrement I, again wrong order, swap the elements, one more time decrement the I, again 15 is greater than 7, so it should be swapped. Okay, now we don't have more elements, so we'll stop it over here. So we'll stop in two conditions: when we don't have elements, or we don't find any exchange at any point. If we find some point there no exchanges are there, we don't need to proceed. See here, now our I would be j minus 1. Now there is no need to exchange over here, you can see. So no need to proceed towards left. Why? Because we know we have started from the left, and all the elements of the left are already in the sorted order. So here we just need to compare the last element, and if some elements we find that it should be greater than less than 24, then we need to compare few more elements. But at the initial stage we are not finding any element. We don't need to go towards left. So the point when you don't find any more elements to compare and swap, we need to stop it there, and we need to follow with j plus 1. So we'll increment just j plus 1, and one more time we will assign I with j minus 1. Compare 32 with 28. Yes, it should be changed. Then I would be decremented. Compare I with I plus 1. No need to change. Stop it there. Okay. So you can see the whole array in proper ascending order. Now I know you exactly got the point how insertion sort works. Now the pseudocode or program would be very easy. for you. So let's see the program, simple C program for the insertion sort. We are following, yeah, one thing I would like to tell you, please keep this thing in mind. Generally algorithm follows from the 0th index and program follows with the, sorry, algorithm follows from the index 1 and program follows with the index 0. So here in this case our first element would be 0, so we have started from j equal to 1 because we need to assign j to the second element. So first of all our key would be a of j, and then we were assigning a I with j minus 1, then we were following I towards left. So two conditions were there, either the elements are not there or we don't find wrong conditions, like in something, some to be comparing two elements are in proper order, so we need to break the while loop. At the last moment when your array goes towards the leftmost way, you have to put this a of I plus 1 to key. This I am giving you in this homework. You need to find why a of I plus 1 equal to key. I hope you will, and I am sure you will find it very easily. You will go through the code and you will get it by here it's written a of I plus 1 equal to key. So if I'll ask how many times this loop will go, remember the asymptotic notation, right? Okay, so you will tell me, yes, obviously n minus 1 times this for loop will run, because 1 from 1 to n minus 1. Perfect. Now what about the while loop? You confused, right? Why? Because we don't know how many times we need to swap the elements unless we know the array. So for different array, different times while loop runs. So from this way we can't find the complexity. So we need to change our direction a bit. How? Let's proceed with equations, like how many times in the worst case, let's take first worst case, how many times the code would run. Suppose worst case, what would be worst case? Worst case would be our descending array. Why? Because in descending array you need to compare the, you have, when you are comparing element, you have to always swap the elements towards the left, because all the elements are in descending order, right? So this would be our worst case, when we have to go through the maximum swappings. So just see, just uh, think it. When the stick would be at the position between 32 and 28, we need to swap for one element. When it would be between 28 and 24, we need to swap maximum for two elements. So this way we'll be having 1 plus 2 plus 3 plus up to, for the nth element, n minus 1 times. So the summation would be the simple equation n minus 1 divided by 2. So it would be n square by 2 minus n by 2. Here n squared term dominates the nth term, right? That is n square by 2 is dominating with n by 2. So we will always consider the higher term in any case, because we are considering our worst case for computing anything. So here our worst case would be order of n square. Let's see now how best case works. See, what would be the best case? The ascending array, obviously, because in this case when you find the one element you don't need to swap, you will be stopped there for that pass. So here you are finding 20 and 24, comparing 20 24 proper position, no need to move your I pointer, right? Just move j pointer. So every time, but one main important thing to keep in mind, even though we are not going to swap any elements, every pass of j we are testing for the first time whether we need to swap or not. So at least we need to run this while loop at least once. So every time we will run this, once we will run this while line, like we are checking the condition for at least one. So for n minus 1 time this will move, so we will have 1 plus 1 plus 1 up to n minus 1 time. So summation would be n minus 1 time, right? Now uh, you will probably ask, like, why we didn't consider the this line key equal to a of j and I equal to j minus 1, because as I said in asymptotic notation presentation also, like, those are constant lines, for it doesn't change for any number of inputs. We need to consider only those lines we are changing with respect to the number of inputs, remember? Okay, so here what would be our best case, that is big omega of n. So in our graph, this blue line with representing worst case order of n square and red line with order of n. So some random array would be in between this. Now let's consider the last thing, that would be average case. What would be our average case? Bit tricky, right? But it's so simple. Like, suppose I'll ask you, I have taken any random array over here. I'll ask you, suppose I'll toss a coin in the air. What is the probability that I will toss for 4 times and every time would be head? What is the best case? What is the best case I am asking you? So you'll say obviously 100%. The probability is 1. Like 100%, the best case would be probability would be 1. That would be our best case. and if I don't get a single time hit, that would be probability 0, means 0%. But if I'll ask what is the random, or means rather than random, what is the average case, so we'll say from 4 times only 2 times will get hit and 2 times tails, so 50%, right? So same strategy we need to apply over here. We will consider that every time we need to swap at least half of the elements. So here while loop moves for the half of the time at least. So in the worst case we were having 1 plus 2 plus 3 plus up to n minus 1. But here our while loop moves for the every j only j by 2 times, right? So our equation would also be divided by 2. So equation would be n minus 1 by 2, sorry, by 4 now. So n square by 4 minus n by 4. Again n square is dominating with n, so here our case would be, average case would be theta of n square. I hope you all gone through all the things and you are grasping what I mean to say. This is the conclusion of our today's topic. Is how you can see the same thing that we have gone through the lecture. If you have any doubt, any query, you can mail me anytime, you can ask me anytime on the pratikcalling@gmail.com. One more important thing I would like to say, I have started posting my videos on the different group of the YouTube, that is algorithm is fun. So go through the algorithm is fun for more future videos, and you will find very interesting videos. Soon we have started with insertion sort, we'll follow different sorts like selection sort, bubble sort, etc. Okay, thank you very much, thank you for giving your precious time. Thanks.